All right, let's get started on systems of equations. Day 2 with substitution. So remember back to the last time we met, we were talking about systems of equations, and we said there were 3 different types of solutions you could get. The most common type, of course, is 2 lines. We're looking for the point of intersection. Okay, we're looking for an x comma y, and that is a one solution problem. And then there were 2 other ones. We had ones that never intersected because they were parallel lines, and this was a no solution. And then we also had one where we had the 2 lines were on top of each other, which was an infinitely many. So this falls back to the different types of equations we can have just with basic equations. So it makes sense that if we have dealing with 2 equations, that you would have those same options. Okay, so let's go ahead and take a look at our do now today, and let's think back to yesterday about what our first step was. And remember, the first x was 1x or 1y. We needed to solve for a 1x or a 1y. So if I look at equation 1 and equation 2, which equation has either a 1x or a 1y that looks like it would be pretty easy to solve for? If you're saying, hey, I see a 1y in equation 1, you're right. That would be very easy to solve for. So we know that to move the 3x, I would have to subtract the 3x. So that would give me y equals a negative 3x minus 5. So now this one is gone. Okay, it's gone. I'm not going to use it again. I'm going to go ahead and cross it out because that way it just keeps things a little bit neater. All right, so now we move on to step 2, which was substitute in. So I need to substitute into 6x plus 2y equals 10. So where is this going to go? The negative 3x minus 5. Is it going to go in for this by the 6 or by the 2? You're right, it needs to go in to the 2 because it's the y. So 6x plus 2, throw my parentheses in there. There's my 10, negative 3x minus 5, and I'm just going to solve it. So go ahead and hit pause right now and then continue to solve this equation. All right, let's see how you did. 6x plus, actually that would end up being minus, wouldn't it? Because I have to distribute that negative, where that negative is there. So let's put that negative in there. 2 times negative 3 is negative 6x, and 2 times negative 5 is a negative 10. Okay, so I'm starting to see something a little interesting here. So I think this might be interesting to me. If I take 6x minus 6x, doesn't that give me a 0x? I'm thinking we might have one of these special solutions. We might have an infinitely many, or we might have a no solution. Because remember, anytime I come up with a 0x or a 0y, that triggers one of those special equations. So what am I left with? I'm left with a negative 10 equals 10. So let's decide, is that true or false? Can a negative 10 equal a 10? Yeah, that doesn't work. So it is false. So what does that tell me? What do my lines look like? How can something be false if it's a system? Well, hopefully you're thinking, oh, those lines are parallel. They're not touching. Okay, those lines are not going to touch. And if the answer is where the lines touch, there's no answer. So this one is a no solution. Keep in mind, it's false. Okay, anytime that result is false and these are not exactly the same, it's going to be a no solution. There will not be a point of intersection. Let's look at the next one. Okay, so this one is already solved for y. That's good. So this is equation 1. This is equation 2. So it looks like I can take this 2x plus 1 and drop it in over here. Okay, take a minute, see if you can hit pause and see if you can put it into the right spot. So substitute it into the right spot and solve for x. All right, let's see how you did. 8x minus 4. I know that since this is a y, the 2x plus 1 has to go in for y. And here's kind of just a quick trick to make sure you know you're right. You can only solve an equation to get an answer like 5 if there's only one variable. So if I'm over here in this step and I have an x and a y, something's wrong. Okay, something's wrong. I cannot solve if there's an x and a y. I can only solve if there's one variable. All right, so distributing, I've got 8x minus 8x. Oh, that's going to trigger one of those again. A -4 and a -4. So again, these guys are the same. And I have -4 equals -4. Well, that's different than the one we just looked at, okay? This one, when I know is true. -4 equals -4, and these are exactly the same numbers. Okay, those are the same numbers. So this one is the line that has the other line right on top of it. So it's intersecting everywhere. It's intersecting everywhere. So because of that, the solution is infinitely many. Every number works because it would be touching here and here and here and here and here and here and so on and so forth. Okay, so on and so forth. So we have to be prepared to solve to see those because that's a possible answer for us. All right, let's solve a couple of them where we don't have infinitely many and no solution just to make sure that we're good on our process. Okay, let's take a look at this one. So we have y equals 5x plus 6 and we have x equals 3y plus 4. So both of these are just fine. They're already solved for y or x, and I just need to substitute. So I seem to do a lot of substituting for y, so let's go ahead and substitute for x this time. So we've got equation 1, equation 2. We're going to use this one to substitute. Just because we can, because you can substitute in for x or you can substitute in for y. The most important thing is you don't want fractions. Okay, you don't want fractions. It always gets messy when we have fractions. Sometimes you cannot avoid fractions. There's just no way, but usually you can. You just have to find some multiples, and we'll take a look at one of those here today too. Okay, so since this is an x, I know that it's going to go here. Okay, go ahead and distribute and see if you can solve for y. So hit pause. All right, let's see how we did. 5 times 3 is 15y. 5 times 4 is 60. There's plus 6. Okay, now, if I remember right, when solving equations, I have to get my variables to one side. So I better move my 15, but I better combine these two. So 60 and 6 is 66. So I have 15y equals 60, plus 66. Got carried away with my equal sign there. And I'm going to subtract my 15y. So I have negative 14y equals 66. And to finish, I'm dividing by 14. So 66 divided by negative 14. 66 divided by a negative 14 is going to give me a negative 4.7. And it's okay to get decimals. It's okay. Not every ordered pair is a perfect integer. Okay, they're not all positive 5, negative 5, positive 7, negative 2. You can have decimals. Okay, you can have decimals. So this is negative 4.71. I went ahead and rounded to tenths. I don't need more than one decimal spot there. Okay, and then I'm going to substitute in. So I'm going to use my x. I'm going to substitute in negative 4.7. So 3 times negative 4.7 is going to give me negative 14.1 plus 4. So x is equaling negative 10.1. Okay, so negative 10.1, negative 4.7, those are perfectly fine answers. And we don't usually get decimals, but you can get decimals. Okay, you can get decimals. And I'm not going to solve them to check them this time. You know how to check them. We went over that yesterday, so just to save time today, so we can have a little bit shorter video. I'll leave that step to you, but don't forget you need to check both equations. And since we are estimating because we're rounding numbers, remember you're just going to be close. So you might end up with like 10.4 equals 10.5, and that would be true. Okay, that would be true. And of course, the dogs are busy this morning. I know that some of you have commented to me as you've watched these videos about the dogs. So at some point, I guess I should show you their pictures so you know what they look like. Okay, now let's take a look at this one. This is the more advanced type of system when you're solving with substitution, okay? I don't have a 1x or a 1y. And the goal is I do not want fractions. Okay, I do not want fractions. If I get fractions, I'm going to have to do a lot of extra work. Clear my fractions. It gets much more messy, lots more steps. And we need to look at the equations and look for what's called multiples or factors. Okay, multiples or factors. So the easiest way to think about that is like what numbers divide into what numbers. So if I think about 16, I know that 2 and 4 and 8 all go into 16. Okay, and if I think about the number 20, I know 2, 4, 5, and 10 go into 20. So the common numbers that they have are 2 and 4. Okay, so if I can think about how those numbers are related when I look at my x and my y, that's going to help me determine which variable to solve for, okay, to eliminate and not have fractions. So let's take a look at equation 1 and let's talk through our option. So if I solve for x, okay, if I solve for x, I'm going to go ahead and do that over here just so we can see what's happening. If I solve for x, I have 4x equals positive 3y minus 16. And I'm going to divide by 4. Well, that's all fine and dandy because that becomes a 4, but I still have a fraction right there. 3 divided by 4. 3 does not divide by 4, ever. So there isn't any way that solving for x in this case is going to clear my fraction. Okay, well then let's look at solving for y. If I solve for y, that means I'm going to move the 4x, so negative 3y equals negative 4x plus 16. I'm dividing by negative 3. Well, that made it worse because I've got negative 4/3 and I've got 16 divided by negative 3. Both of those are going to be fractions. So as you can see, I definitely do not want to use the first equation. Now let's look at the second equation. Notice how I have a 2, and a 10. Can I divide by 2? If I take 2 divided by 2, I'm going to get 1. If I take 10 divided by 2, I'm going to come up with 5. So I see that these are multiples of each other. Okay, those are multiples of each other. So that tells me I'm safe. I can use those to divide. So I can solve for x or I can solve for y. It doesn't matter. I think let's solve for y this time. We haven't done that for a little bit. So negative 2y equals a negative 2x minus 10. Remember, we moved the 2x and it became negative. I'm going to divide by negative 2. So y equals negative 2 divided by negative 2, that's a 1, positive, and negative 10 divided by negative 2 is positive 5. So all of a sudden, I have a much simpler equation. And equation 2 is now y equals 1x plus 5. Okay, so here's your equation. 4x minus 3y. Get my pen back here. Okay, go ahead and substitute in. See if you can solve for one of the variables. All right, let's see how you did. Remember, this is y. So I'm substituting in where the y is. So distribute. Negative 3x minus 15 equals a 16. My 4x drops. I'm going to combine my like terms. 4x minus 3x is 1x. And I'm going to move my 15. So 1x equals 31, which is the same as x equals 31. And it's perfectly fine to come up with variables equaling larger numbers, because systems are used a lot in applications and modeling of real life scenarios, and our numbers are definitely not all between 0 and 10 or 0 and negative 10. So you're going to expect to get some larger numbers. All right, go ahead and hit pause and see if you can come up with the y value. Okay, let's see how you did. So we know that x equals 31. So am I going to want to use equation 1 or equation 2? You're right, I want to use equation 2. I always want to use the one that I manipulated, because that one will be the easiest one to solve for. So y equals, I have 1 times 31. I don't really need to put that 1 in there, but it's there. So 31 plus 5 is going to give me 36. So y is equal to 36. So there's my solution. And checking is exactly the same way. Substitute in for your x and your y and go from there. All right. So at this point, we're done for the day. And we really want you to be working on understanding the substitution, checking your answers, reaching out to us if you're struggling. Remember, there's 3 types of solutions. There's no solution, one solution, infinitely many. You're solving for an ordered pair. Let us know if you are struggling, and we look forward to seeing you next time.